This is part 3 of the Mosaic tutorial. In this part we are going to register, normalize and integrate the entire Mosaic by registering the individual Mosaic panels. I'm going to show how to do this step by step. First we need to load our images. I have set my working directory to the place where my panels are, the integrated Mosaic panels. I have renamed them myself, so I know which panel is which in the entire composition. We have the 5 panels at 135 millimeters, and we have 6 panels at 400 millimeters. I load them. Let's have a look. So this panel was shown earlier in one of the tutorials. We will be using this frame as the reference frame in registration as well, because it's the most center part of the entire field of view. Let's have a look at panel 1, which is all the way on the left side. Panel 5. We can check the other panels. Let's look at panel 6. Okay. Let's look at another one. Okay. Well, to register these panels to a mosaic, first we'll have to do analyze stars. Like I indicated before, this data has a lot of stars. Therefore, I increased the minimum star size to 6. So only bigger stars are taken into account. And in this case, what helps is disabling the automatic minimum star target. I just set it at a level on which we detect a lot of stars. In this case, for this data, it is kappa 25. Let's look for this frame. We can check it by showing the star map of this data. It will use the settings which are set here. So, and in this case, using these settings, we have set the automatic maximum stars target at 5,000 stars, and in this case, up detects about 3,700 stars. You can see they are a little bit elongated, the stars. But there you go. These are good settings for this data. We click on Analyze Stars, and we wait for it to finish before continuing with registration. So star analysis is almost complete now. There it is. We can check the details in the number of stars column. As you can see, most panels indicate about 5,000 stars with the full width half maximum values, which look fine. Now we continue to registration. And what we will do, we are going to use pentagons because we have a lot of stars. This will make the registration a bit more robust and probably a bit faster as well. I'm going to set skill start at 5 and skill stop to 10, as you can see over here. I'm going to enable dynamic distortion correction, which is really necessary in this case, because we are making a mosaic. If you don't enable it, we will see that registration will be off. We need to disable same camera and optics. In this case, we need to disable it because we have panels of different focal lengths. But if you create a mosaic, I suggest you keep this at disabled for best results. The mosaic registration is a bit more flexible then. If you would enable it, the registration engine will make certain assumptions, and if those assumptions aren't correct for the data, the mosaic registration could fail or could be worse than we want. The registration mode needs to be set to mosaic, and the registration model we can keep at default, projective. And let's click on start registration. Oh, hang on, I am forgetting something which is vital. I want to set the reference frame manually in this case. Astro Pixel Processor chose panel 6 as the reference frame. Well, let's look at our mosaic, how it is composed. This is panel 6. Taking that as a reference probably isn't ideal. I'd rather take panel 3, which is in the middle of the entire field of view. So I'm going to set panel 3 as my reference. Set reference. Yes. Click on panel 3. As you can see, the reference frame is now panel 3. And we click on start registration. We'll need to wait for this process to complete. There are quite a lot of stars, and Astro Pixel Processor will scan for each frame how the other frames are attached to it. Okay, registration is nearly finished now. The registration engine has now finished verifying how each frame is attached to each other frame in the mosaic, how each panel is connected to each other panel. In the console you can find the multiple view calculation of the mosaic. It's performing it right now. As you can see, it is converging nicely to a low root mean square error. It's nearly finished. So that's that. Let's check the result. In the registration RMS field we can find the registration precision of the mosaic. The entire mosaic has been registered using 12,000 star pairs between all frames with a precision of only 0.4 pixels. What we can do now, we have panel 3. We can have a look at how registration looks. Oh, it's now loading the star map. Hang on, I'm going to load it linearly. So this is panel 3, our reference frame. let's load it registered. So what will happen now, it will show this frame in the entire mosaic, in the entire field of view of how the mosaic is composed. Since this is a big field of view and each panel has lots of pixels, this field of view is rather big, as you will see. There it is. You'll notice that frame 3 is in the middle, as we would like. Well, let's have a look at another panel where it is located in the mosaic, as it is oriented right now. You can see it's oriented vertically at the moment. We will fix that later. We are loading one of the long focal length panels, panel 8. I think it's over here somewhere. Yes, there it is. Okay, the next step what we'll need to do is normalization of all panels. You have the choice over here to use regular or advanced. For most mosaics it's recommended to use advanced. In this case I noticed that if I use regular with a low degree of LNC in integration, the result is already fine. It's really good. So I'm just using regular normalization. And we'll wait for it to finish before proceeding to integration. Okay, normalization is now nearly finished. There it is. All qualitative results are reported over here, as usual. We proceed to integrate. What we'll do, since this is a mosaic, we are going to weight each panel equally, and we're going to use average integration. I'm going to set local normalization correction to 2nd degree with maximum amount of iterations. I'm going to use multiband blending at 10%, and my goal using these two settings is to get a seamless mosaic with a flat sky background. It's important to note that LNC will not automatically make your background flat. It will make sure that illumination differences between the panels are corrected. Any resulting gradients after integration with LNC still need and can be corrected with the remove light pollution tool. Okay, let's set it. 2nd degree, 10 iterations. I'm going to enable multiband blending at 10%. I'm not going to use outlier rejection, it's not needed. I keep everything at default, long source interpolation, no drizzle, and we click on integrate. One final check, equal, average. Yes, click on integrate, and the integration will start. So each mosaic panel is now loaded. The registration parameters for the mosaic are applied. Then the data is normalized, and then it is added to the stack for all frames to be integrated. Okay, all mosaic panels are loaded to be integrated, and local normalization correction has now started. We are going to do 10 iterations. As you can see, the entire field of view is big. We can get information from the integration. It will be 490 megapixels. That's big. That's the reason that for 11 panels the integration task requires 30 gigabytes of free hard disk space. Okay, the local normalization correction will take some time for this big field of view, so we have to be patient for it to finish. Okay, as you can see right now, local normalization correction has done 4 iterations. It's now working on the 5th one. From the root mean square value, error value, you can see per channel. Channel 1 is the red channel, channel 2 is green, channel 3 is blue. You can see per channel that the root mean square error is dropping. This means that normalization locally in the stack is improving at each iteration. The 10th iteration of local normalization correction has finished. It's now applying the found correction parameters to the data. After that, the integration of the entire Mosaic will start. Okay, the integration is now nearing completion. It's analyzing the integration result. It's being saved. So this will be a very big file. The file is about 2000 megabytes, so 2 gigabytes large. Image dimensions of the Mosaic are 9000 by 18,000 pixels. And let's check out the Mosaic. It's being loaded right now. It's a very big file. It's 2 gigabytes large. So there it comes. There it is. There is the Mosaic. As you can see, this looks very nice. Zoom in. So all the Mosaic panels have been integrated very nicely using both LNC and multiband blending. I don't see Mosaic seams. You can turn saturation, you can turn on saturation a bit to see more. So I have created this Mosaic on the original image scale. So the scale factor is 1.0. If you would reduce the scale factor, you would integrate it to a lower image scale, or the higher image scale, I should say, which means you will have smaller image dimensions, making it a bit faster to create the Mosaic. Let's do a strong stretch to see all details. So that's a pretty strong stretch. We can increase saturation even more. So let's zoom in. So this panel has been integrated very nicely. You can see over here there was a overlap region. It looks very good. I can't see the little panels anymore over here. So this looks very good. Like I mentioned before, local normalization correction will correct for illumination differences. The current implementation will not yet make your sky background flat. So the residual gradients that you see over here and in these corners at this border, we'll need to correct that with the remove light pollution tool, which will be discussed in the next part of this tutorial. So the next step in the tutorials will be light pollution correction, gradient removal, background calibration, star color calibration. I will perform selective color on the data, and in the end I will tweak the preview filter settings to make a nice image for publication. Before we start with the next part, I'm going to rotate the mosaic so it will be oriented horizontally. We can do this with one of the tools. It's the batch rotate resize tool. I want to use it on the image in the image viewer. And what we'll do, I'm going to rotate it counterclockwise 92 degrees. Counterclockwise 92 degrees. I'm going to use Langsos 3 data resampling, data interpolation, because that will preserve the data as best as possible. We'll first create a preview by clicking on show. So it will show the rotated data in the image viewer. So this is a very big field of view, so it does take a little bit of time. It's nearly finished. There it is. I think this is a good rotation for this field of view. We can create a very nice crop from the data in the end. So I click on OK to save this. The data that you see, of course, is still linear. It's only showing so bright because of the preview filter over here. So all data up until now has still been linear, and it will stay that way until the final step in which I actually apply the preview filter settings. I'm going to save this again as a FITS file. And you can see it over here at the bottom, other processed, and you can see it's 92 degrees counterclockwise rotated. So the next part will come now. It's correcting the gradients, the light pollution in this data.